All right, this is a worksheet that you guys would do in class, and then we would go over it. So we would, work, get it done, and then check it. So I'm going to go ahead and check it. If you need to pause this recording, that is fine, but I'm not going to be doing the typical time that I spend on it. So let's go over with this if we were doing it together. -7 needs classified as many ways as possible. So if I gave you these 5 numbers on a pop quiz, or numbers like this, could you classify them without a word bank? So right now, you need to make sure you use your graphic organizer with the number sets and make sure you know your terms. -7 is real, it's rational because it's a terminating number, and it's an integer, positive or negative whole number. 3/4 is real and it's rational. Remember, rational numbers can be written as a fraction, a terminating or repeating decimal. Square root of 6 is real and it's irrational because it is a non-terminating decimal. We always want to look and see what the number is. 3.16 with the 6 repeating is real and it's rational because it is a repeating decimal. It is rational. 0 is real, it is rational, it is an integer, but it's also a whole number. It is not a natural number. Natural numbers start with 1, then 2, then 3, then 4. All right, a set is a collection of items called elements, and that is the symbol for element. So if you see something like X with an E, it's saying X is an element of maybe the natural numbers. And I did put the symbols here to help you remember what the abbreviations are. Okay, if you have an empty set, you would see the null set or an empty set. Now, if a set is finite, we can count the number in them. All right. So finite would be discrete. It might have a 1, 2, 3, 4 in it. There's 4 numbers. We can count them. It's cut off. If something is infinite, it has unlimited elements. That means it would keep going like a pattern, or it could be between 2 numbers. The number, if I go from 1 to 2 and I pick any real number from 1 to 2, that is infinite because it's continuous. So any of those decimals. All right, a couple more reminders here. We can describe sets in four ways. We can use words to talk about it. All right, so there's some examples. Roster notation is where we list it. It can be used for finite and infinite sets because you might have . It is not used for continuous, so it must be discrete. So roster notation is a list. We have interval notation, which was new to us, so I have some notes here. Sometimes it's between 2 endpoints, sometimes it's to infinity. Okay, always represents an infinite set because it's continuous in between. Curved, like a parenthesis. So a parenthesis means it's not included. That's from less than or greater than, or an open circle. And a bracket symbol means the endpoint is in the set. So it could be less than or equal to, greater than or equal to, or a closed circle. Other reminders, you're going to use negative infinity if it goes forever to the left, positive if it goes to the right. Infinity will always be in parentheses. Interval notation always goes from low to high. So pay attention to that, especially with your infinity symbols. And then if you have more than one interval, the word or comes into play, which is really a union of 2 things. And we use that union symbol, that U. All right. And then we have that last one, and it's set builder. Set builder is the most forgiving. Set builder can use words, it can use equations, inequalities, and we can use that element symbol there. So if you look at this, here it is, X such that, that's what that stands for. X such that, that's the bracket, the X, and then the bar. X such that 8 is less than X, which is less than or equal to 15, and X is an element of the natural numbers. Okay, what's this mean? 8 is not included, but 15 is. Now, if I didn't have this here, it could be anything. It could be 8.1, 8.5, 8.001, as long as it's not 8, and then it can be any number up to and including 15. But they said that X is an element of the natural numbers. That's what that N is. So that means that it can't be 8.1. The next natural number that's above 8 is 9. So the list would be 9, 10, 11, 12, 13, 14, and it would include 15. So this would be in roster notation. And the only reason I can do this in roster is because they're only the natural numbers. Again, if this wasn't here, I would have a continuous graph, something that would look like this. Okay, so we talked about that. You can read through this again. The set of all numbers less than 3 is showed like this. X is X such that X is less than 3. On a number line, you would have an open circle at 3, and then everything below it would be shaded. Okay, and so interval notation, we would have negative infinity to 3 with the parenthesis. Now, this one, the set of all positive even numbers, X such that X equals 2n, and n is an element of the natural number. I can't show this one on a number line because they're only positive even numbers, where this one was all of the numbers. All right, so if I put 1 in here, 2 times 1 is 2. If I put 2 in here, it's the next natural number. 2 times 2 is 4. So I could list these. Again, only natural numbers work. So 2 times 1 is 2. 2 times 2 is 4. Put a 3 in here, 6. And what's going to happen is I'm going to keep going. And anytime I multiply something by 2, I get an even number. And again, I can only use the numbers 1, 2, 3, 4, and onward because it's naturals. So this could be in Set Builder, and it is continuous. And I could do it in interval also. This is in Set Builder, and because of the equation and defining as a natural number, I know it's not continuous. It is infinite, but there's nothing between 2 and 4. It's discrete, and that's why I can use roster. Okay, describe each set in interval notation. So you can see I have closed circles here. The low is -1, the high is 4, both in brackets. As an inequality, that'd be -1 is less than or equal to x, which is less than or equal to 4. Now, this one's a little different because I have an open circle, still the same low and high. Bracket, like an equal sign, it's included, parenthesis because it's not, and that would be -1 is less than or equal to x, which is less than 4, and that's what it would look like as an inequality. All right, this one starts at 4, not included, and then the high is infinity. That's what it looks like in interval notation. Just to help, x is greater than 4 is what we would see as an inequality. So if I have the inequality, a lot of times I'll graph it so I see the interval notation. That helps. Okay, this one has 2 intervals. That's why we're using the union symbol. Negative infinity, it stops at -1, and it jumps. So it's either down here or it's up here, 4 to infinity. As an inequality, x is less than -1 or x is greater than or equal to 4. And I have some questions about Set Builder. Any of these things that I wrote as inequalities could turn into Set Builder if I just came in and I put an x with the bar. Now I've turned that inequality into Set Builder. X such that this is true. And in Set Builder, we can get more specific and give more descriptions, but I don't need anything else because it is continuous. Okay, now, oh my gosh, I already did this. So down here, I wasn't paying attention. Class Practice 3, describe the sets from Class Practice 2, boom, in Set Builder. So all I have to do is take that inequality idea and put the x on front of it. So I just showed you that. Take the inequality we did, x such that. So take the inequalities and build them. So take a second, double check that. I guess I thought it was important, and here it was because it was right here. Now, Class Practice 4 says, could roster notation, could roster where you list them, be used to represent any of these sets? No. All of these sets are continuous. I can't list the numbers between -1 and 4. I can list the integers, -1, 0, 1, 2, 3, 4. But I cannot list all of the numbers, and anything counts. Any small decimal counts. So no, roster notation cannot represent continuous sets. Okay, now some of you are good with this, and so you should have this tried on your own, and let's go over it. We are looking at writing these out in 3 ways. So I don't think these are too complex of examples. Let's cover this up. They gave me the number line and they gave me the inequality. X is greater than, so open circle shade up here. So put this in interval notation. This can get tricky, so go to your graph. The low is 2, the high is infinity, and that's why it keeps going both in parentheses. Set Builder, just take your inequality, brace x such that x is greater than 2, and in words, I have x is any real number greater than 2. All right, next one, closed circle shading to the left. X is less than or equal to 2. So don't go from 2 to infinity or 2 to, it has to be low. The low is negative infinity. The high is 2 with a brace or bracket. Okay, set builder, X such that X is less than or equal to 2. X is any real number less than or equal to 2. All right, next one. Notice there's an open circle here. We talked about one of these. Anything below it, anything above it counts. 2 is the only thing it can't be. So this is where X can't be 2. So it can be any other real number. So you have two intervals. It starts at negative infinity. It stops and does not include the 2. Or jumps over. It starts but does not include the 2 and it goes to infinity. Set builder notation. I could write two inequalities. I could write X is less than 2 or X is greater than 2, or I can simply put this in here. Right here, X is any real number except 2. All right, last one. We have two intervals going on. -1 is less than X, which is less than 1, not included, or 3 is less than X or equal to, which is less than or equal to 4, both included. Interval notation, low to high, union, second interval, low to high included. Again, set builder, we just put it right in here with X such that, and then we write it out in words. All right, so just a reminder, the brackets include the endpoints like closed circles. The parentheses do not include the endpoints. All right, now that we've done this, you should be good on your 3 sets of notations. Don't forget about roster. I'm going to write the word roster up here. Roster is the one you list. I cannot use roster on any of these because it's continuous. So roster, interval, and set builder are the 3 notations. Please make sure you know your number types and classifications.